Hi everyone. My name is Balogun Philip, and I'll be talking to you today about like real-time applications and what we learned building Jetstream. First of all, I'm from the content intelligence team, and one of our goals, or what we're trying to do, is to make data actionable. And most of the time, it's for the editors trying to make data actionable, allow them to get insight into how articles are performing on the homepage, what's going on this article, what's happening here, what can they do to actually get something different or get the best out of different things they have going on. So that's basically like being like the core thoughts around all the products we've tried to work on so far. And that definitely includes what I'll be talking about today, Jetstream. So first of all, what is not Jetstream? So if you actually Google, Jetstream is not a fast-flowing, narrow air current in the atmosphere. Definitely not that, but it was like a real core point of the inspiration for the name of what we call our product. And if you watch a lot of animes, specifically Naruto, if you hear the word fast-flowing current or air, you think about some kind of like air jutsu or something. That's on the side though. But what exactly is Jetstream? So this is Jetstream. This is what we were able to work on. So it's a platform where you can actually like go and get insight on how articles are performing on the homepage. What exactly is happening on this article based on like referrals, based on search, based on like different metrics. And you can actually like get to like correct them based on like time filters. So what's happening over today, the last 2 hours, the last 1 hour, and the last 30 minutes. And you can basically filter for any category you're looking for, from news, politics, and everything. A little information about why we wanted to build this. So we previously been using WebTrack to actually like get this insight, or used by the editors to kind of like see how articles are performing on the homepage in the day and everything. And we decided to migrate to use Adobe Analytics, and they happen to have like some live stream data, and we thought we could actually build something nice with it. So here we are. So Jetstream basically just helps them get all this insight into like how articles are performing, from having like spark lines and metrics and values for the entire day. You can actually compare down to what's going on yesterday on the article to today, while still comparing on all the different metrics. And you can filter based on like for the SEO team, for videos, for premium articles, for like articles on mobile and for desktop. And this is at the moment serving both Velt and Built. So like most projects, it kind of like starts as a POC, quote unquote, and it kind of like turns out to be like the first version. And we had like, it was the first time we building something like this. So we had like lots of questions and kind of like wanted to just walk through our thoughts and approaches of what we try to do. So first we have like this is how our architecture kind of like looks like. So we have like a Node.js application sitting down here and connecting to Adobe Analytics, getting the data. So yeah, basically what we just did here was like to clean up the data from the stream, map like the metrics data from like values, eval values and others to something, and props to something that we can actually like utilize and use that makes sense. So we did a lot of that in this the Node.js application here, and we're pushing down to Firehose. And if you've done work with Firehose before, it's a tool by AWS that allows you to like load real-time data into streams, storage, and you basically can publish that to another stream or to an S3 bucket and things like that. But what we did here was to send it down to Kinesis at Data Analytics, which is another tool by AWS that basically allows you to like, get insight out of data in real time. We just, write some SQL queries and you can get insight from data. You basically can get the querying blocks, and you can aggregate based on some timeline, 30 seconds, 10 seconds, whatever works for you. And you can actually like publish the output of these also into another stream. So what we ended up doing here was get data here. We have stored also to S3, and we basically did some queries and had some kind of like output we wanted to like get from it. So we had two outputs, one of them which we call live data metrics, which is kind of like the metrics and counts of like the articles, how the page impressions are, conversions, referrals from search, referrals from social media, and things like that. And we also have like metadata information, which is kind of like information about the article URL, the article ID, and things like that. So this was going into Lambda, and we're basically saving it down in a database. So this is kind of like the inflow of the data into the system. And from this part here, basically like the user trying to like access the data. So we have the user accessing Jetstream and, getting the response from API Gateway, Lambda, and, talking to our database to actually get the data. So one of the first things we felt we could do, because rather than having to do some joins on like the live data and the metrics, because one of the major things we're trying to do is to provide spark lines. So each article kind of like wants to have a spark line, so you can kind of like get a tale of how the article has been performing over time from when it was published. So we thought about having some cache tables here. So the tables for 30 minutes, tables for 2 hours, tables for today, which was like the initial filters that we had, which is right here. So we were basically doing some kind of like quick aggregation for like the top articles in the last 30 minutes, the articles last 30 minutes, and basically like publishing it into like this table, so like we can easily just get them out of it quickly for the last 30 minutes, for the last 2 hours, and for today. And we're basically updating them by DB events. And the front end was getting updates on how like this article numbers are changing and the sparkline data trend by doing some kind of like polling. And based on how we're getting data from Kinesis data analytics, we had to do like some insert on conflict, which basically was allowing us to like, we could get like, for example, we have like 1 million, let's say, rows being inserted into like Kinesis analytics, and the query basically allow us to, let's say, 500, and we would probably get the same data, so we could do insert on conflict to kind of like do some sums on similar data and in aggregate for the particular timestamp. So in the end, this didn't turn out to be so helpful because we're getting a lot of like table locks, and we're basically having like events being really slow. So since we're actually caching data, the events were not able to get access to the live data table, and what we're displaying to the user was like lagging behind by from 10 seconds to a minute sometimes at first. So we took out on conflict and found a way around it to just basically insert the data and just keep on doing like the aggregations and trying to map it when we are creating the temporary tables, which helped a lot. Then for the spark lines, we thought about, we could actually do the same thing that we're doing here for having like temporary tables, because we kept on getting like new filters. 30 minutes was 1 hour was later introduced, so we kind of like doing the same thing, and we had like spark lines right here. So we did the same to kind of like get spark lines for the last 30 minutes, 1 hour, 2 hours, then get them into like cache table. And that kind of like help update the speed at which you're able to update the tables and make the data more accessible and quick. And back here, when we did the update of these tables for like the timeline, we basically were doing like a complete fresh update. So we're basically recreating the tables all the time, and that wasn't so optimal. So one of the things we ended up doing moving forward was to also like try and fetch data for only the recent changes, so we can basically just publish that into into like the temporary tables. So we're doing like minimal insert into the temporary tables, and we're cleaning up the data over time. So we were actually like doing less insert, and we're like having almost little to no backlogs on data, which is really cool. And since we kept on having like new timelines that might maybe come up every once in a while, so we said so we could move, rather than having like sparkline tables to match the time filters, we thought about having things in buckets. Also, so we can actually allow users to like zoom into how an article is performing on like a big scale. Let's say if you're looking at data for like an article for today, a 10-minute time bucket rate for data points might actually makes more sense to you. That if you want to zoom in, you can actually get something 4 minutes and 2 minutes. And we can actually use the same sparkline rate limits to actually like be able to plot the spark lines for 30 minutes. 30 minutes basically use like a 2-minute data rate and not having to have like a matching table for it. And that also like really like help improve the system performance so far. And so far, so good. It's been really fast, and we're also thinking more about what else can we actually do to do it. So we thought about using Cloud Firestore. And this is a service by Google, and what this allows you to do is you could basically like push changes down here, and the changes could be cached, and some kind of like a socket IO service. So you basically can publish changes to the front end as opposed to having to pull the data every 30 seconds. So what we could do is what we're doing right now is that we get the queries the user wants to apply, and since the user could basically do one-to-many kind of filters on the data, maybe you could want to have news without politics, news with politics. So we basically cache the request. The requests get stored on Firestore. We have like the Lambda here, basically pull the requests. We fetch the data from the database and store them there temporarily. So multiple users are actually trying to access the same type of queries, which are kind of like hashed, will get the same result and get published updates when there are like changes. So we kind of like found a way to track the queries that actually come up top with like multiple requests and try and update them more frequently than the others. So they get the data published to them, and that's currently what we have at the moment. So it's still basically still monitoring this and see the benefit that it's offering so far, but just having to take off the load of the database and down into like some publishing service and basically like seeing some really good improvements in the service so far. And that's what we have at the moment. And then what we learned and what helped, so having CloudWorld Insights to be able to debug the performance of like the database when we like started off was really good. We could actually go in and see what's going on in Firehose, where we needed to get some increase in our limit from AWS because we're having more records, especially during the spike.
Philip, you muted yourself.
Oh, okay.
Now you're back. Great.
So having CloudWorld Insight actually allows us to kind of like see what's going on the different parts of the system from Firehose, because we have like limits on how many records you can write per second and the number of records you can write per second. Also have like a data size and how many instances of the node service we're connecting to Adobe service live stream data that we could actually have running, and also debugging the database Aurora. Having alarms also, because there are some times we have like downtimes we're not getting data from Adobe, and we're like, so those are things we actually had to really like let us know when we could actually react, and using DB procedures. So this is actually really interesting because we were just basically having to have DB events just basically do the updates for the temporary tables which you have, and which worked, but when there were errors we're unable to actually catch them. So having to like use DB procedures for like events stuff being triggered by events allows us to like maybe handle the exception properly and have those exceptions being inserted into table, and we can actually track the queries and everything properly and more quickly. So that was also really nice to have, and what we figured out over time. And what's still a pain is database migration at the moment, because every once in a while we have to like do some like adding some new columns for some new metrics, and this actually takes time to get into the tables because it's happening on like a live system, and we have to like schedule that during like when we have lower inflow of data into the system. So that's what we have at the moment. One of the good things we do have is that with Firehose and analytics, whenever we have like failure to actually insert data, when we're having like really the system was a bit slower. The first version we're having like on conflict, we got like retries from Lambda, from kinetic analytics. So we get like retries, and Lambda get retried to the data is actually inserted into the database. So that really helps. What else we haven't, what's the pain? Data migration, and what we haven't tried yet, other databases. So this was like a first version, and it was meant to be like a POC, but you know how POC always turns out to be like the first version of what we do. So that's like what we've been using so far, but we haven't actually tried exploring other database. So we've had some good things about Elasticsearch, which we might basically explore in the future, but at the moment what we have seems to work very fine for us. And that's basically everything we've been able to like walk through so far. We launched Jetstream February, so it's kind of like our experience and what we've done so far, starting from last year down till this very moment. So that's it.